Hi, this is the next homework video. This is homework 10. Okay, so the next section is 6.9.2. Number 1. So if capital X is a random variable having a normal distribution with mean mu is 2, and standard deviation sigma is 0.5, find each probability. So for part A, we want to find the probability that X takes in a value greater than 3. So X is a random variable that has a normal distribution. So this is a normal random variable, not a standard normal random variable. Okay, so you want to convert this to a standard normal random variable Z. So this is going to equal to the probability that X minus mu over sigma is strictly greater than 3 minus mu over sigma. So the inequality stays the same if I subtract each of them by mu and then divide both by sigma. Sigma is positive, right? It doesn't. When you divide by a positive number, it doesn't change the order of inequality here. Well, so mu here is less than X. Well, no, so X minus, it's fine. X minus mu and 3 minus could be negative. You're dividing by sigma, which is positive. Okay, so this is equal to the probability that X minus mu, which is 2, divided by sigma, which is 0.5, is greater than, X minus mu over sigma, that's Z. That's standard norm. That's Z is your standard, is your normal, standard normal random variable. Okay. Right, and so in the lesson it taught you how to convert a normal random variable to a standard normal random variable. You take X minus mu divided by sigma. So that's greater than 3 minus mu, which is 2, divided by sigma, which is 0.5. And so that's equal to the probability that Z is greater than 3 minus 2, which is 1, divided by 0.5, which is 2. So this probability that Z is greater than 0.2. What's the probability that Z is greater than 0.2? That's equal to 1 minus the probability Z is less than or equal to 2. That's equal to 1 minus the probability that Z is less than or equal to 0, plus the probability of 0 less than Z less than 2. And that's equal to 1 minus probability Z is less than or equal to 0, which is 0.5, plus the probability that Z is between 0 and 2. And so by the table that I gave you guys, that is equal to 0.4772. Okay, so that probability is 0.4772. That's 1 minus 0.9772, which is 0.0228. So the probability X is greater than 3 is equal to 0.0228. Okay, that's part A. Part B. Okay, so part B. So X takes in a value less than 1.5. So what's the probability that X is less than 1.5? Quite curious. That's equal to the probability that X minus mu over sigma is less than 1.5 minus mu over sigma. That's equal to the probability that Z is less than 1.5 minus mu, which is 0.5, divided by 1.5 minus 2. It's 2 divided by sigma, which is 0.5. That's equal to the probability that Z is less than 1.5 minus 2, which is negative 0.5, divided by 0.5, and so that's negative 1. Z is less than negative 1. That's equal to 1 minus the probability that Z is greater than or equal to negative 1. And that's equal to 1 minus the probability that Z is greater than or equal to 0, plus the probability that negative 1 is less than Z, less than 0. Okay, and so that's equal to 1 minus the probability Z is less than or equal to 0, which is 0.5, plus, now you're going to take that probability, that's plus the probability 0 less than Z less than 1. And so 1, that's 0.3413. 1 minus 0.5 is 0.5 minus that probability, which is 0.3413. which is 0.1587. So the probability that x is less than 1.5 is 1.1587. That's part B. Okay. Let's do part C. Okay, so then part C for number 1. Find the probability that x takes on a value greater than 2.5. That's equal to the probability that x minus mu over sigma is strictly greater than 2.5 minus mu. So right, minus 2 over sigma, which is 0.5. That's equal to the probability, well, x minus mu over sigma is z. Probability z is greater than 2.5 minus 2, which is 0.5 divided by 0.5, which is 1. Probability z is greater than 1. That's equal to 1 minus probability z is less or equal to 1. That's equal to 1 minus probability that z is less or equal to 0, plus the probability that 0 less than z, less than 1. And so this is equal to 1 minus 0.5 plus this probability, which is okay, I just did this one, 0.3413. And so this is 1 minus 0.8413. And that's 0.1587. Okay? So that's C. Okay, and so part D. So for part D, find the probability that x takes on a value less than 1. This is the probability that x minus mu over sigma is strictly less than 1 minus mu, which is 2, divided by sigma, which is 0.5. That's equal to the probability that z is less. 1 minus 2 is negative 1. Negative 1 over 0.5 is negative 2. Probability that z is less than negative 2. That's equal to 1 minus the probability that z is greater than or equal to negative 2. And so that's equal to 1 minus the probability that z is greater than or equal to 0, plus the probability of negative 2 less than z less than 0. And so this is 1 minus probability z is less or equal to 0.5 plus the probability that 0 is less than z less than 2 by symmetry. And so this is equal to 1 minus 0.5 is 0.5 minus this probability, which by the table is 0.4772. And so 0.5 minus 0.4772 is 0.0228. And so that's the answer to the probability x less than 1. Okay, so that's part D. And then part E. Okay, so part E. The probability that x takes on a value between negative 1 and 1. Okay, so that's equal to the probability negative 1 minus mu over sigma is less than x minus mu over sigma, which is less than 1 minus mu over sigma. That's equal to the probability negative 1 minus 2 over 0.5 is less than x minus mu over sigma is z, which is strictly less than 1 minus mu, 1 minus 2 over 0.5. That's equal to the probability of negative 2 is less than z, less than negative 1 minus 2, negative 6. It's negative 3 over 1/2, which is negative 6. 1 minus 2 over 1/2 is negative 2. And so that's equal to the probability that z is less than negative 2 minus the probability that z is less than or equal to negative 6. if you're looking at the values between -6 and -2, you want to know the probability that C is somewhere between here and here. So this is 1 minus the probability that Z is greater or equal to -2, minus this thing, which is 1 minus the probability that Z is greater than -6. So this is equal to 1 minus the probability that Z is greater or equal to 0 plus the probability that -2 is less than Z less than 0. Okay, minus now 1 minus this probability, which is the probability that Z is greater or equal to 0. I'm going to put a bunch of brackets here, so follow the brackets. This is Z greater or equal to 0 plus the probability that -6 is less than Z less than 0. Okay, so I wrote all those brackets there. And so what I'm going to do is I'm going to now, that final probability, which I said was equal to all these things, I'm just going to erase these things. So this is equal to 1 minus, well, that's 0.5 plus, now this probability is probably the Z's between 0 and 2 by symmetry. And that probably is 0.4772. Okay, now that's minus 1 minus probably Z is greater or equal to 0, which is 0.5, plus, now by symmetry, that is from 0 to 6. Okay, so this is actually, because the probability, if you look in the table, the probability that 0 is less than capital Z less than little z, your variable, when this is 3, when that's 3, this is 0.4999. It's almost a half there. And so when you go from 0 to 6, you're basically getting to 0.5, but you can use the same number. So 6 is just larger than 3. And by the time you get, so if you want to know the probability of from 0 to 6, it would be more than this, but it's not, it's less than 0.5. It's at most 0.5, but at least that. And so you can say this is approximate, you can say this is 0.5. And so now this, so I guess maybe I overkilled this. So then this is that. That's 0.5. That's the 0.5 here. Okay, so then this is equal to 1 minus 0.9772 minus 1 minus 1, which is 0. Okay, so this is 0.0228. Okay, so that's part E. Okay, so that's 1A through E. Okay, let's go to the next section. So this is 6.10.2. Okay, number 1. So 6.10.2 says, how might you estimate the average income of residents of a very large city without finding the income of every resident? What theorem may be used to justify this method? Okay, so what you could do is, by the strong law of large numbers, you can say the sum from I equals 1 to little n of x of I over n is approximately the mean mu with great probability if n is large. And so this is by the strong law of large numbers. So by the strong law of large numbers, you can say that if you observe the random variable x n times, and where x of I is the value each time you observe it, you sum them up and you divide by little n, it's approximately equal to mu, with great probability if little n is large. And so if you want to estimate the average income of residents of a very large city without finding the income of a resident, then just add up the incomes of a large number of residents and divide by the number of people you asked. And then that would be approximately the average income. Okay? So you would use the strong law of large numbers to justify that. And so when x of I is the income of resident I, where I goes from 1 to little n, then if you just find the income of little n many residents and you add them up and you divide by little n, that's their average, and it's approximately equal to the average with great probability if little n is large by that law, the strong law of large numbers. Okay, and so that's 6.10.2, number 1. Okay, and so we will stop there, and I'll see you next time.